Welcome to this explainer. Today we're looking at a totally everyday sight you probably walked right past this morning without a second thought. But hidden inside this totally ordinary scene is an absolute masterclass in physics. How does a fragile little bird casually perch on a high voltage power line without getting completely zapped? Okay, let's dive into this.
It's a fantastic question, right? We know electricity is incredibly powerful, and that line is pumping a massive 240 volts. That is way more than enough to cause serious harm. Yet, there the bird sits, completely unbothered by this invisible, raging river of power rushing right beneath its claws. So why doesn't that immense energy just push right into the bird's body?
Section 1. Seeking lower energy states. We often think of electricity as this wild, chaotic force, don't we? But it actually follows a really strict set of rules, and this brilliantly illustrates that rule. To quote Izhar Ahmed from the iPhysics channel, electricity never just strikes at random, it only travels when it has a path to a lower energy state. Basically, electricity isn't just sitting there waiting to jump into the bird. If there's no lower energy state to travel to, well, it simply will not move. So, to really understand what a path to a lower energy state actually means, we got to talk about something called potential difference. Potential difference is basically a gap in voltage. Think of it like a gradient or a hill that electrical current literally requires in order to flow. Without this gradient, that massive energy running through the line, it just won't push its way into the bird. It's simple. No potential difference, no movement. Section 2. The math of safety. So how does this gradient thing apply here? Well, visualize a bird coming in for a landing. Both of its feet grip the exact same continuous 240-volt power line. Because of this, its left foot and its right foot are experiencing the exact same voltage. There is absolutely no gap, no hill to slide down. So the crucial point is that the mathematical difference in voltage between the bird's left foot and its right foot is exactly zero. Zero. With zero potential difference to drive the charge, the resulting current flowing through the bird is absolute zero. It perfectly adheres to Ohm's law. The electricity just ignores the bird entirely and continues along the wire, taking the path of least resistance. Section 3. The deadly exception. But, physics is pretty unforgiving. Let's move to and see how this builds into a completely different and unfortunately tragic scenario. On the one hand, we have our safe setup, right? Both feet on a single line. Totally safe. But imagine the bird stretches its wings and accidentally brushes a second, lower voltage wire nearby. Instantly, the math changes. A massive potential difference suddenly appears between that 240-volt wire and the wing. And because electricity aggressively seeks that lower energy state, a deadly current is forced right across the poor bird's body. Section 4. Support IPhysics. Now, what's really interesting about this slide is that the breakdown of this whole avian mystery comes directly from Izhar Ahmed over on YouTube. If you love discovering the hidden mechanics of the world as much as we do, I highly encourage you to support creators who make this stuff so accessible. Seriously, go ahead and like this explainer, make sure to subscribe to the iPhysics channel, and definitely share this knowledge with your fellow science lovers. I want to leave you all with this final thought. Today we learned how a simple mathematical zero, literally a lack of potential difference, forms an invisible shield protecting a fragile bird from a massive amount of energy. So, knowing that electricity is always seeking a lower energy state, what other unseen rules of physics are secretly keeping you safe right now without you even realizing it? Keep looking closely at the ordinary world around you guys. Thanks for joining me on this explainer, and I'll catch you next time.